In this lesson, we're going to take a look at binary ionic compounds, how to write the chemical formula, and how to name them. So a binary ionic compound is a compound that has two different kinds of monoatomic ions. So monoatomic meaning that it comes from one kind of atom only, or one kind of element only. So two different monoatomic. Sodium chloride is an example of that. Sodium is one element, chlorine is another element, and so one sodium and one chlorine coming together. So monoatomic, once again, just means of one type of ion. So sodium and chlorine there are each different ions there. A cation is when we are positively charged, and remember we talked about the T in cation looks a little bit like a plus sign to help you there, and an anion is a negatively charged ion. We can use the N in anion to help us remember the N for negatively charged. So when we write the formula for a binary ionic compound, we are always going to write the metal cation first. So remember, ionic compounds are a metal and a nonmetal. So the metal is going to be the first in the name. The nonmetal, which is the anion or negatively charged ion, is going to be second. And when we name them, the metal is going to be the full name of the metal. And for the nonmetal, we're going to drop the ending of the name of the element, and we're going to replace it with the suffix "ide" or IDE. So for an example, sodium chloride, so that's made of sodium and chlorine. Sodium is the metal, that comes first, full name, and then chlorine, the element chlorine, so the name, the ending gets dropped, the "ine", and we add "ide" at the end. Lithium bromide, so lithium is the metal, bromine gets changed to bromide. Aluminum oxide, so aluminum is the metal, oxygen is the nonmetal, and the ending gets dropped to become oxide. And just a clarification here, in case when we were talking about monoatomic, you thought it meant that we can only have one atom of that element. We can have multiple atoms of each element, but we have a single type of element making up the cation and a single type of element making up the anion. So that's what two monoatomic. So the cation is made up of one element, and the anion also made up of one element. And then you can require one or more atoms of each of those elements. So we can make a prediction on the compound's formula if we know what ions are in that compound based on the charges. So for example, if we look at the compound magnesium chloride, so here we're given the name and we're going to figure out what the formula for that is going to be. So first we're going to write the symbols in order. So magnesium first and then chlorine. And then what we're going to do is write the valences above the symbols. So magnesium is in group 2, which would mean it has 2 valence electrons. And in order to have a full outer shell, magnesium could either lose 2 electrons or it could gain 6. And it's easier to lose 2 than to gain 6. So it's going to lose 2 electrons, meaning it has 2 more protons now. So it has a valence of 2. Chlorine, on the other hand, is in group 7. So there are 7 valence electrons, and it's easier to gain 1 than to lose 7. So its valence is going to be 1. And here, we don't need to write the charges. We can just use the numbers. But if you prefer, you can also write the charges in. That part is up to you. When we move them down, then we are not going to use the charges at that point, just the numbers. So step 3 is that we are going to crisscross the valences. So the magnesium, the 2 from magnesium goes to chlorine as a subscript, and the 1 from chlorine goes to magnesium. So I need 1 magnesium for every 2 chlorine. Then I'm going to look at those 2 numbers, so I have 1 and 2, and if I can bring those down, if they're not in lowest terms already, what I'm going to do is divide them by the highest common factor. So here, 1 is the biggest number, so I can't divide it by anything else anyways. So that isn't going to change. And anytime we have a subscript of 1, we're going to remove that. So magnesium chloride is MgCl2. So if there's no number written there, as there isn't over here, and that probably wasn't wise because it looks like a 0 instead of a circle. I'm circling the emptiness there. If I'm writing it, it means there's at least 1 there. If there's more than 1, I would specify that. If there's none, I wouldn't be writing the symbol at all. So it's kind of like 1x in math, where I don't have to write the 1 in front of it. If I have no x's, I wouldn't write it. And if I have more than 1, that's when I clarify. So just to show why this happens, so magnesium, like we said, is in group 2. It has 2 valence electrons. Chlorine is in group 7 and it has 7 valence electrons. So we said chlorine has a valence of 1, which means that it needs to receive 1 electron. And so if this electron from magnesium comes over to here, that chlorine is now happy. It has a full outer shell, but the magnesium still has 1 electron in its outer shell and it wants none. So we need another chlorine here to accept that second electron. That chlorine now has a full outer shell. Magnesium has now lost both of its electrons. So the outer shell, the shell underneath is now a full shell. And what was the outer shell is now empty. So the shell underneath is full. So they're both happy. So we needed 1 magnesium for every 2 chlorine. Now the other way that might help it make sense is magnesium is a 2+, which means it's going to lose 2 electrons. Chlorine is a 1-, which means it's going to accept 1 electron. So to balance my charges out, if I have 1 of those, 1 times 2+ is an overall charge of 2+, and 2 chlorines each gaining 1 electron means that overall I have a charge of 2- there, and then that will cancel out. So that's just showing I have 2 electrons being lost and 2 being gained. So whichever one of these is going to help to understand where the electrons are moving and how we are coming up with this overall formula. So MgCl2 for magnesium chloride. Okay, so at this point, barium sulfide. So if you have your periodic table out, look up barium and sulfide. So you've got the 5 steps. So the first step is writing the element symbols. So first barium, then sulfide. The second step was to write the valences. Third step's crisscross. Fourth step, do a lowest terms of those. And then the 5th step was to remove any 1s there. So at this point, I would pause the video and try this on your own to see how that goes. Okay, so I'm going to keep going. Hopefully you've paused and done this and you're just checking. So we have barium and sulfide. Sulfur I know is in group 6, which means it needs 2 electrons to gain, and barium I'm going to double check. I believe it's group 2. Whoops. There we go. No. Oh goodness. I'm forgetting how to. There we go. Barium is indeed in group 2. Okay. So that makes it a 2+. So first step was writing Ba and S. Second step is the 2+ and 2-, or 2 and 2. Third step is to do the crisscross. So we have Ba2, S2, and then 2 and 2 can each be divided by 2 to leave us with 1 and 1, and I don't need to write 1s. So once again, to show this, barium has 2 electrons, and sulfur has 1, 2, 3, 4, 5, 6. So we have 1 electron can come here, 1 can come here. So I only need 1 of each. The 2 electrons that barium has in its valence shell will be taken by sulfur, and so I actually only need them in a 1-to-1 ratio, so 1 of each of them. Okay, and that is how we write formulas for ionic compounds, and also how we name ionic compounds if we have the formula.